to projects. In this video, we are going to explain about the project, which is tagged autoencoder based intrusion detection system to combat financial fraudulent. Introduction of the project. In the rapidly evolving landscape of the internet and the society, the profound integration of digital technologies has transformed the way we live, study, and work. With a particular emphasis on financial transactions with a smart digital environment and urbanization, supporting industrialization, the project recognizes the critical role of secure digital services in safeguarding sensitive aspects of individuals' life. The increasing deployment of Internet of Things, which are IoT devices, enhances smart digital environment but also introduces significant security challenges. The heightened data traffic in wired and wireless networks associated with smart digital financial services creates vulnerabilities, making it possible for intruders to disguise themselves as legitimate service providers. The emergence of various advanced cyber threats underscores the urgency of addressing security concerns given the potential for substantial financial losses resulting from successful attacks. The project acknowledges the necessity of effective intrusion detection systems, such as IDS, in identifying and mitigating network attacks. It distinguishes between network intrusion detection and host based intrusion detection systems based on disruptive behaviors. NID focuses on analyzing network traffic to detect potential risks, while HID operates locally on machines, examining diverse log files to identify threats. The project highlights the limitations in current intrusion detection systems, particularly those based on deep learning models. Issues such as high false positive rates for unknown attacks, lack of model transferability, and insufficient documentation of evaluated models underscore the need for advancements. Despite the remarkable capabilities of deep learning, its application in IDS requires addressing these challenges for improved efficacy. The project introduces a novel approach to intrusion detection using deep learning. Specifically, it proposes an unsupervised stacked autoencoder for pre-training the data, followed by supervised deep neural network, which is DNN, acting as an intrusion detection model classifier. This design aims to reduce the reliance on manual feature discovery and enhances the system's ability to distinguish between normal and attack events, providing a more robust and efficient solution to address evolving cybersecurity threats. Objective of the project. The primary objective of the project is to develop an effective intrusion detection system leveraging stacked autoencoder, which is AE, and deep neural network, which is DNN technologies, to address the escalating security challenges in IoT environments. The focus is on securing digital financial transactions and urbanization services where the potential for network attacks is significant. The project aims to employ a stacked AE to perform unsupervised feature learning on the input network records. By reducing the feature width through this process, the system aims to enhance its ability to distinguish between normal and potentially malicious network activities. Another objective is to train a deep neural network in a supervised manner to extract deep learned features for effective classification. This step aims to further refine the system's ability to identify and categorize network activities, particularly in context of digital financial transactions. The project seeks to evaluate the proposed ideas on publicly available datasets, which are KDD Cup 99 and NSL KDD dataset. The objective is to assess the system's performance across different scenarios and types of network data to ensure its robustness and applicability in diverse settings. The ultimate objective is to demonstrate the effectiveness of proposed ideas by achieving high accuracy in multi-class classification. The project aims to validate the system's performance with the accuracy rates on the KDD Cup 99, NSL KDD, respectively showcasing its capability to accurately identify and classify various network activities. To implement the project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement the project, we have designed various steps in the flow of work. The first step is importing the packages. In this step, necessary Python libraries and packages are imported. We have imported NumPy and Pandas for data manipulation, scikit-learn for machine learning, Keras and TensorFlow for deep learning, and Seaborn and Matplotlib for visualization, Flask for web development. Exploring the dataset. Here, two datasets which are KDD Cup 99 and NSL KDD are explored to understand the structure, features, and content. This involves loading the datasets and examining basic statistics or characteristics to gain insights into the data. The next step is data processing. Here we have substeps, which is converting pandas data frame. Here, the dataset is converted into pandas data frame, which is a convenient data structure for further analysis. Keras data frame. Here, the data is prepared in a format suitable for Keras, which is a deep learning library. Dropping unwanted columns. The columns that do not contribute to the analysis or model training are dropped to streamline the dataset. Visualization using Seaborn and Matplotlib. Data visualization tools, Seaborn and Matplotlib, are employed to create visual representations of the data. This helps in understanding patterns, distributions, and relationships within the data. The next step is label encoding using label encoder. Categorical data, if it is present, is converted into numerical format using label encoder. This is crucial step as many machine learning algorithms require numerical input. Feature selection. Feature selection is performed to choose the most relevant features for the model. Mutual information is used as metric to assess the dependency between features and the target variable. Here we used select percentile method for feature selection. Appending features. The selected features are appended to X and target variable to Y. Splitting the data into train and test. The dataset is divided into training and testing sets. The training set is used to train the machine learning model and the testing set is used to evaluate its performance. Building the model. In this step, deep learning models are defined and constructed. Training the model. The model is trained using the training dataset. During this phase, the model learns the patterns and relationships within the data to make predictions. Flask framework with SQLite for sign up and sign in. Flask, a web framework for Python, is used to create a web application. SQLite is employed as a lightweight database for user sign up and sign in functionalities. User gives input as feature values. User provide input in the form of feature values which are relevant to the problem being solved. The given input is pre-processed for prediction. The user provided input is pre-processed to ensure it aligns with the format required for the model prediction. This step includes data cleaning and transformation. The next step is trained model is used for prediction. The pre-processed input is fed into the trained machine learning model for prediction. The model uses its learns patterns to make predictions based on the provided features. Final outcome is displayed to frontend. The prediction outcome is displayed to frontend of the web application, allowing users to see the model's responses based on the given input. Algorithms which are used in the project are deep neural network, which is DNN. DNN is a type of neural network with multiple layers between the input layer and the output layer. It consists of an input layer, one or more hidden layers, and an output layer. DNNs are known for their capacity to learn complex hierarchical representations from the data. DNNs are commonly used in the projects involving complex pattern recognition and feature learning tasks. In this project, DNN is employed for its ability to capture intricate relationships within the dataset, making it suitable for tasks such as intrusion detection, where identifying subtle patterns in network traffic is crucial. The next model is autoencoder using DNN. An autoencoder is a type of neural network used for unsupervised learning. It consists of an encoder, which compresses the input data into a latent space representation, and a decoder, which reconstructs the input data from this representation. Combining an autoencoder with a DNN involves using the compressed features learned by the autoencoder in a subsequent DNN architecture. Autoencoder DNNs are effective for feature learning and extraction. In this project, combining DNN with an autoencoder suggests a focus on unsupervised pre-training to capture essential features in an efficient and compact manner. This is particularly beneficial in intrusion detection, where understanding the intrinsic structure of the network data is vital. The next model is LSTM using autoencoder. LSTM is a type of recurrent neural network which is RNN architecture designed to capture long-term dependencies in the sequential data. An LSTM autoencoder combines the principles of autoencoder with the memory capabilities of LSTM networks to learn temporal dependencies in the sequential data. LSTM autoencoders are suitable for tasks involving sequential data, such as time series or network traffic patterns. In this project, the use of an LSTM autoencoder suggests a focus on capturing and reconstructing sequential patterns in the network data, which is crucial for detecting anomalies or intrusions over the time. As an extension, we applied a hybrid method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built the front end using Flash framework for user testing with the user authentication. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate this project. So here we have comparison graphs for all those metrics for the dataset, which is KDD Cup 99. It is a widely used dataset in the field of intrusion detection. It contains network traffic data representing various types of attacks and normal activities. This dataset is a standard benchmark for evaluating intrusion detection systems. So here we have accuracy comparison graph. Here on x-axis we have accuracy score for each algorithm, and on y-axis we have algorithm names. Similarly, we will have for precision, FN score and recall. Accuracy is a measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision comparison graph. It is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall comparison graph, which is also known as sensitivity or true positive rate. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. It is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. Here we have comparison graphs for the NSL KDD data. NSL KDD is an updated version of the original KDD Cup 99 dataset, addressing some of its limitations. It offers a more balanced distribution of attack types, reducing biases present in the original dataset. So this is the accuracy comparison graph, precision, recall, and F1 score. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project, and this is the dataset folder in which we have KDD Cup dataset and NSL KDD dataset. We use these two datasets for training the algorithms. This is the static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. These are the two IPynb files, which are the Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. This is the signup file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, paste the copied path and then click on enter. By this, current directory will change to the code folder's path. Here we need to type the command python space app.py and click on enter. This will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flash framework will host the application locally at the default address, which is the local host and the port unless configured differently. This is the local host and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser. And this web page is built by using the Flash framework. So first we need to click on sign up link. And here we need to enter all the sign up details if we are signing up newly. I have already signed up and have an account in it, so we'll directly sign in. For that, click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. And now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see the parameters which are need to be entered. Based on the given parameters, we will get the prediction whether attack is detected or not. So before entering the parameters, we will understand them. The first one is protocol type. This refers to the type of protocol used in the network communication such as TCP, UDP or ICMP. It specifies the rules for data exchange between devices on the network. Here we have service. It denotes the network service or the application associated with the communication. Each service operates on specific ports and has its own communication patterns. The next one is SRC bytes, which is source bytes. This represents the number of bytes sent by the source, which is originating entity in the network communication. The next one is destination bytes. It indicates the number of bytes received by the destination, which is receiving entity in the network communication. The next one is logged in. This indicates whether a user is logged into a system or not. The next one is count. It represents the number of connections to the same host as the current connection in the past 2 seconds. The next one is SRV count. Similar to count, it specifies representing the number of connections to the same service. The next one is SRV different host rate. It calculates the ratio of connections to the different hosts to the total number of connections. The next one is destination host count. Similar to count, it focuses on the number of connections to the same destination host. The next one is destination host SRV count. It represents the number of connections to the same destination service. The next one is destination host same SRV rate. It calculates the ratio of connections to the same service on the destination host to the total number of connections. The next one is destination host different SRV rate. It calculates the ratio of connections to the different services on the destination host to the total number of connections. The next one is destination host same SRC port rate. It calculates the ratio of connections from the same source port to the total number of connections. The last one is destination host SRV different host rate. It calculates the ratio of connections to the different destination hosts for the same service on the destination host. Now we understood all the parameters, so we will enter them. Protocol type is 1, service is 56, SRC bytes are minus 0.03003, destination bytes are minus 0.026, logged in value is minus 0.417, count is minus 1.530, SRV count is minus 1.168, and the SRV different host rate is minus 0.203. Destination host count is minus 3.5133, and the destination host SRV count is minus 1.7221. Destination host same SRV rate is 0.599. Destination host different SRV rate is minus 0.2828. Destination host same SRC port rate is minus 0.835, and the destination host SRV different host rate is 7.6337. And now we will click on predict. Based on the given parameters, we got the prediction as there is no attack detected and it is normal. Now we will enter the parameters again, but with the different values. So I entered all the parameters. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is DDoS. Now we will enter the parameters again, but with the different values. So here I have entered all the parameters. Now click on predict. Here we got the prediction as there is an attack detected and the attack type is probe. Now we will enter the parameters again. I entered all the parameters. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is DDoS. Now we will click on sign out. In this way, if we enter all the parameters to the system based on the given parameters, the system will predict whether attack is detected or not. If the attack is detected, it will detect which type of attack it is. Conclusion of the project. The project excels in robust intrusion detection using advanced technologies like deep neural networks and autoencoders, ensuring a proactive defense against potential network threats. Also, extension models performed well. Diverse parameters by leveraging unsupervised learning through autoencoders and incorporating LSTM for sequential analysis, the project demonstrates a progressive approach to feature learning, enabling the nuanced understanding of the temporal dependencies in the network activities. The project significantly contributes to combating financial fraud by securing digital financial transactions within smart environments. With its ability to detect anomalies and potential threats in the real time, the model plays a crucial role in ensuring the integrity and safety of financial transactions, protecting individuals and businesses from potential financial losses. The seamless integration of the Flask with SQLite for user management, along with a user friendly front end, showcases the project's practicality. The user centric design positions the model for deployment in diverse real world scenarios, ensuring accessibility and usability for end users.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.